All right, let's figure out this review. How are we going to do it? Problem number one. Problem number one says, determine if the function is one-to-one. If so, graph its inverse, function at -1 of x, on the same set of axes, and clearly show the reflection over the line y equals x. Additionally, create a t-chart of ordered pairs for both function at f and its inverse to show their relationship. Okay, let's see if I can make this somewhat. Okay, so we're creating a t-chart. First thing we want to see is the one-to-one. What test do we have to use on these to see if they're one-to-one? Horizontal line test. Horizontal line test passes, then it is a one-to-one function. So we wanted to create a t-chart. Where's yours? You were here yesterday. Really? What? Sorry about that. All right. Created a t-chart, so I have -6 is this point. -4, 0 is this point. 0, 1. And 4, 4. It's one-to-one. The horizontal line test passes. So if we're going to create our inverse, we're just going to flip-flop everything. So we're not going to see that change. That's obviously staying right there. Get a light. This is going to yield me 0, -4. So 0, -4. 1, 0. And then 4, 4 is still going to be the same point. So if we connect the dots. And then they said, show that it goes over this line, which is y equals x. So that is what the graph and its inverse look like. It is one-to-one because the horizontal line test passes. I'm going to borrow this here, write down the next example. Put it right back here. And then for the next one, is there any questions on that? Should be pretty easy. For each of the following, 2 through 5, find the equation for the inverse. State the domain and range of both the original and the inverse functions. Okay, so number 2, we have function at x is equal to 3x minus 6. Problem number 3, we have function at x is equal to x to the third. Problem 4, function at x is equal to x plus 3 over x minus 2. And problem number 5. All right, so problem number 2, domain, range. Perfect, so the domain of this is negative to positive infinity. Ranges, same thing. Can my inverse also have negative infinity, positive infinity for both? So there's no restriction on the original, so the domain and range of the inverse could also be the same, but it also might have a restriction. Okay, let's change this to y equals 3x minus 6. Flip-flop x and y. Solve for y. That answer is totally fine. Some of you might have this as an answer. Either of those answers are fine. So circle that one. You could add the one above it circled as well. I do have a denominator, but I don't have an x down there, so there's not going to be any restrictions. What would the domain and range be of that? Can I plug negative, positive, infinity in for x and get something out for y? Yeah. If I plug negative, positive, infinity for x, are there any y values that stick out to you that I won't have? Let's say this is also a domain, negative to positive infinity. God bless you. So inverse, original function, domain and range of each. Sound okay? We're just going through that sheet we did yesterday. Okay, x to the third. Can I plug any values in for x? Everything's going to work there. Kind of have to know what the graph's going to look like. It's going to go like this. Have a little wiggle in the middle, but it's going to go like that. So is it going to go forever up and down too? You guys awake? All right, so y equals x to the third. Flip-flop x and y. And solve for y. So I'm going to get the third root of x is equal to y. So y equals the third root of x. There's my inverse. So my domain and range of the original were not restricted, so it's possible my, God bless you, your domain and range of your inverse will also not be restricted. Can I have negative third roots? Yes. Third root of negative 8 is negative 2. Third root of 0 is 0. Third root of 8 is 2. So that's going to work. So my domain will easily be negative to positive infinity. My range, I think it would be the same thing. So this graph would look like this, while this graph is going to look like this. So same idea, negative to positive infinity. That okay? Problem number 4. Is there any restriction going to take place on this one? If so, why? 2 can't equal because the denominator becomes 0. So my domain is going to go from negative infinity to 2, from 2 to infinity. The reason it's rounded brackets at each because we're avoiding 2. I'd say as far as the range goes, if I have positive numbers plugged in, I'm going to get positive numbers out. If I have negative numbers plugged in, depending on what negative number it would be. Degree on top is equal to degree on bottom. So the horizontal asymptote is going to be y equals x. So I'd say the smallest value of my range is going to go from 0 to infinity. Inverse. Pretty sure you're going to see one very similar to this on the quiz tomorrow. How am I going to solve for y? So let's multiply both sides by the y minus 2. So I'm going to get y minus 2 times x equals y plus 3. Let's distribute, so I get x times y, or xy minus 2x is equal to y plus 3. ideas. Okay, subtract 3 over. I got a y on both sides. Divide by x. If I divide everything by x, this becomes y over x. But I like your thinking. Let's talk for one. What would happen if I did this? What did I do? I just moved the xy over, so I subtracted it. How can I get y alone? Do I? If I divide by it, I will have on the left side negative 2 over y, or negative 2x over y, and negative 3 over y. And that'll be equal to 1 minus x, so I still have 2 y's to contend with. Square root it. I like the idea. It might get pretty ugly. Yeah?
Take out a y.
So factor out a y on the left, or on the right, excuse me.
Yeah.
I like it. So on the left side, nothing's going to change. And me and I have a GCF here of y, so I'm going to change this to y minus x. Is that the same thing? If I redistribute that y back over, do I get y minus xy? What's the last thing? Divide by 1 minus x. Awesome. Divide by 1 minus x, so I'm going to get y is equal to negative 2x minus 3 divided by that. I don't know why I put in parentheses, but I did. Let's see. What values can we not have here? 1's not going to work. So my domain, I'm going to go from negative infinity to 1, 1 to infinity. My range, degree on top is equal to degree on bottom, so you take lead coefficients. You know what I goofed up right here. Degree on top equals degree on bottom, so lead coefficient, that should be a 1. Sorry about that. Degree on top is equal to degree on bottom. So I'm going to get a horizontal at negative 2 over negative 1, so y equals, my lead coefficient will be 2 over negative 1, which is negative 2 over negative 1, which is negative or positive 2. That's kind of an uglier problem. Is there anything about that you want me to go over more, discuss, argue about? Okay. What do we know? Domain. Nope. That's square root. Square roots, I can't have a negative under the radical. So what's the smallest value I can plug in for x? 0. Can I have a square root of 0? What's the square root of 0? 0. So we can. So the domain of this is going to be square bracket, negative 2 to infinity. The range, let's think about this. If I take the square root of any numbers, will it ever be negative? No. So I'd say the range can go probably from 0 to infinity. Change functional notation to this. Flip-flop x and y. Let's see. Square both sides. Subtract 2. What kind of shape is this? It's a parabola. We have to be careful though. This is a portion of a sideways parabola. If I graph this, it's going to look like this. Okay? this is a parabola, but it's got to be restricted. So this shape is going to look like this. Okay, I can't have the other side. I can't have the negative component to it. So using that picture there, what does my domain appear to be? Where do I start in the x direction? So 0 to infinity. Range appears to be -2 to infinity. So it does actually look like we just flip-flop those, but so be careful on some of these. That'll be definitely something you might see tomorrow. So don't go, oh well sweet, now I can do negative positive infinity and probably get the range right. Borrow your skin. Okay, is 0, 4 on the graph the inverse? Is 4, 0 on the graph the inverse? And what point A comma B is on both the inverse and the original? Should we find the inverse to see if this point's going to work? So if we find the inverse, I get this. Y equals 2x plus 4, flip-flop x and y. That should be our inverse. So let's check to see if 0, 4. How would I check to see if 0, 4 is on that? Plug it in. So I have an x and y value. So is 4 equal to 0 minus 4? 0 minus 4 is negative 4. Negative 4 over 2 is negative 2. Is 4 equal to negative 2? Not today. Okay, plug 4, 0 in. Again, this is an x and a y value. So if I plug 4 in for x, I get 4 minus 4, which is 0. 0 divided by 2 is 0. 0 equal to this 0? Yep. And what point is on both graphs? Let's graph the original, see if this will let us flow in. So I have a y-intercept of plus 4. A slope up to right 1. And then my inverse is this. That's the same thing as 1/2 x minus 2. So I'm going to go up 1, right 2. It looks like they're going to cross. How do I know? Looks like they're going to cross. They have two different slopes. That's it. They're definitely going to cross because we have two different slopes. How do I know where they're going to cross?
How do you go?
Yeah. I mean, I did draw it, but I just rough drew the. You put it in your calculator? Yeah. Yeah. Go ahead.
They cross when the points are the same number.
Like -5, -5 or something like that? Could be. What's my definite? It's definitely negative, negative. You're absolutely right. But what's the negative, negative ordered pair? Any ideas?
Set it equal to each other.
Oh, I like it.
Set it equal to each other. Alright, so I'm going to call the first one y equals 2x plus 4. Call the second one y equals x minus 4 over 2. So I'm obviously not going to set the y's equal to each other. But if I set the other side equal, I'm going to get 2x minus 4, or excuse me, 2x plus 4 equals x minus 4 over 2. If I multiply both sides by 2, I'm going to get 4x plus 8 equals x minus 4. Subtract x. Subtract 8. You are, not everyone else will. Yeah, I'll choose one student at random each time. You're the one random one. That's part of it. How do I find the other one? Either, yeah. Which one? Might have got the question right. Man, can't take it anywhere. So take negative 4, plug it into either of the equations. Doesn't matter which one. I'll plug it into the first one. So I have y equals 2 times negative 4 plus 4. So that's negative 8 plus 4. So my y value is negative. What'd I do? So negative 4, negative 4. That exists on both. Like it. What? Oh, good. Sarah praying again. Her head's down. It happens. A couple people praying today in the med class that I had to go make sure that they're still praying. Oh. What? There's nothing wrong with prayer. I'm not trying to take away from it. What?
Did you really?
All right, number 7. All right, this problem, they tell us this, and they tell us they want us to say 7 and 8 both. Okay. So they tell you it's 1 to 1. So this means this yields a point 3, 11. And this inverse allows you to have this. Okay, so till it's 1 to 1. So the inverse of this is going to be 11, 3. And the inverse of this is going to be 9, 2. So the inverse of top is 3, 11. So what is the function at 11 equal to? Function at 11 is equal to 3. The function at 9 is equal to. What did I do? Oh. So what about the function at 9? So that means we want the inverse of 2. Perfect. So realize this is the statement 3, 11. Its inverse is 11, 3. So they're asking for the inverse. What happens at the inverse at 11? We get 3 out, so on and so forth. right, we want to identify the horizontal asymptote. Play back. So these are exponential functions. Horizontal asymptote. What does the 2 do? Shrinks it? Does this negative flip it over the x or y axis? X? Y? Which one? So if I plug like 1 in, I get 4 to the 6th power, which is huge, times negative 2. So if I plug 1 in, I plug 1 in, I get 4 to the 6th power, huge number, times a negative becomes a negative huge number. So 1 comma, way down here. If I plug negative 5 in, negative 5 plus 5 is 0, 4 to the 0 power is 1, 1 times negative 2 is negative 2, so negative 5, negative 2. What? X-axis. I just thought you were yelling at her. C. So this is doing something like this. You think? Horizontal asymptote. What am I approaching? Am I getting a negative 2? I just showed when I plug negative 5 in, I get to negative 2. Hard bracket, negative 2. That means it'd have to start there. What would happen, let's say if I plug negative 6 in, negative 6 plus 5 is negative 1, 4 to the negative 1 is 1/4, so 2 times 1/4, or negative 2 times 1/4 is negative 2/4, so that's negative half? Approaching 0? Okay, I think so. So my domain of this, alright, let's do this. Horizontal asymptote is going to be at y is equal to 0. So this line right here. And then, so my domain is going to go from negative, or it's going to go from 0 to negative infinity. Yeah, wait. Go with that. My domain is going to go from negative to positive infinity. Does it ask for the range? Did it ask for the range? It does. So then the range is going to go from 0, rounded bracket, because we won't get there, to negative infinity. What's going to change the horizontal asymptote on these? What do I have to do to the function? What do I have to do to change the horizontal asymptote? So I'm going to say that a horizontal asymptote is going to be 0 for the most part. Yeah? So like add here, outside? Yeah, absolutely. Stop, she's going to start crying. Alright, this is what I'm going to do. I want to get up through number 11 and then give you the rest of the time to work on this, and then we'll finish up going over it tomorrow.
And then take the test Thursday?
Is that okay?
Yeah.
You sure?
Yes.
But someone's got to make sure, Sleepy over here is no longer sleeping or praying. If she is, we're going to shave her eyebrows off. Never done that, Alex?
I'm going to.
You ain't shave yours?
No, just on like a baseball trip. Just one eyebrow. Sweet.
I had a student a long time ago, Alex.
Yeah.
You might know. You know Hunter Martin?
Sounds familiar.
He's probably the funniest kid I've ever taught in my life. Love the kid. He's a Marine now. Kid named Hunter Martin I had. And yeah, eventually. So Hunter Martin says, dude, I'll bet you anything I'm going to ace this test that I was going to give. I said, all right, what do you want to bet? He goes, I don't know what you bet. I said, I'll shave my eyebrows off if you ace it. If you don't ace it, you shave yours off. He's like, dude, deal. Does it right for the whole class. He gets a 21%. I'm like, they're coming off? He's like, no. I mean, the kids gave him so much grief for the rest of the day. Oh. Like, Jerp's going to make you shave your eyebrows off. So did he do it? Never did it. But, huh? I'm not a welcher. I would have taken them off. Then they would have grown back looking like, you know. Hi, I'm Mr. Stirrup. Who's this freak? He looks like Bert from Sesame Street. Oh, gosh. Realize this, Luke. I was the grader of his test. I'm pretty sure I could have found an error someplace. I was safe in that bet. I don't get multiple choice. All multiple choice? Sure. Normal?
That's what you just do.
Her face? What?
And like the other half is
All right, 10. We just discovered the horizontal asymptote. What's the horizontal asymptote on this one? Negative 1.
We should do the final before the final.
You got it. We'll do it tomorrow.
Oh.
And everyone gets done, you have to come back and flash the rest of your.
Oh, okay. Alright.
All right. Hey, why is the horizontal asymptote negative 1 on this one? It was 0 on the last one. We are subtracting negative 1. Okay, what does the negative exponent do to this graph? Does it flip it over the x, flip it over the y, adjust it in any other way?
move it to the left.
Move it left? Why does it move left?
Down 1.
Down 1?
So you got the wrong one.
All right, T-table it. Shh. All right. What? T-table? What'd you do? All right. If I plug negative 1 in, negative 1 plugged into negative x becomes positive 1. Shh. Let me get through this, please. God bless you. If I plug negative 1 into negative x, what value is it? 1. So 2 to the first is? 2 times 3 is? So 6 minus 1 is 5. So negative 1, 5. Like it? Plug 0 in. 2 to the 0 is 1. 3 times 1 is 3. 3 minus 1 is 2. If I plug 1 in, 1 plugged in for negative x is negative 1. 2 to the negative 1 is 1 half. 3 times 1 half is 3 halves, which is 1 1/2. 1 1/2 minus 1 is 0.5. So this is a decay model. That negative x flipped it over. What is my domain going to be? Well, I can plug pretty much any value I want in, get something out. What does my range appear to be? There you go. The reason why I know that is because we know the horizontal asymptote is that because of that right there. Hey, how you doing? Thank you for a little. Okay, he's here. Uh-oh. You need to go now. Now. Aeneas, if you start running now, we'll vouch for you that you ran that way and you really went that way. I would hate to be an office aide that delivers anything to my rooms ever.
Think you're lucky.
They like don't notice that you said
You should make them.
they like no reaction. What are they supposed to say?
Like, you guys know where I got that term from. Good luck.
Thank you.
If all else fails, blame Grotto for everything. Okay? Grotto, you can start running now. They won't catch you. Last one for today. Last one for today. What do you think? What's the horizontal asymptote going to be?
3.
Love it. X minus 1. That's not really going to change it. This is still going to be a graph that looks like this. Do something like that. It's definitely growth. Just because it's X minus 1, all that really technically does, it's hard to see, is shifted the whole graph right 1. So the domain, pretty sure anything in the world is going to work. While the range is going to go from 3 to infinity. And guys and girls, you have the rest of the period to work on the rest of that review. We'll finish up tomorrow. I just don't feel good. But don't worry, we have a few days built in, so you should be